This is Chapter 7a, Part 1 on linear equations. In this chapter, you'll learn how to solve linear equations with an unknown on one side, and we will emphasize strongly in this episode on clearly showing your work when solving equations. So before we move forward, in order to solve algebra problems, it's important that first you understand this idea of collecting like terms. So like terms are basically terms that have the same variable or the same quality about them. So if we look at number 1a, we see 2x plus 3x plus 6y minus 4y. Now if we isolate each term, 2x, and the positive sign goes with the 3x, so plus 3x, so positive 3x. And then we start to see y's, so positive 6y and a negative 4y. What we have to do now is we have to combine terms that look alike. X's and y's, they don't look alike, so we cannot combine them. 2x and 3x together, they make 5x. Now, 6y and negative or minus 4y. So if you think about it, 6 minus 4, well, that makes 2y. Now, the thing is, we can't just write 5x and 2y. We actually have to connect the two terms with a plus sign, a minus sign, a division, and so forth. So what we have to look at is, well, 6 minus 4, is that a positive 2 or a negative 2? Well, it's a positive 2, so we attach the positive sign to that, so the expression that gets written out is 5x plus 2y. Let's do another example. 1b. So you have 5x plus 2y minus 3x plus 6y. I'm going to go ahead and box the like terms. So 5x and negative 3x are like terms, and remember to always include the sign that comes before the term, because that tells you if you have to add or subtract, because it tells you is that number positive or negative. Now we have to combine the y's, so you have a positive 2y and you have a positive 6y. So here we go, 5x's minus 3x's, well, that makes 2x's, and 2y plus 6y, well, that makes 8y. And that 8y is positive. So I'm going to go ahead and write plus 8y. Now, of course, it doesn't matter which order you write them in. You could also write them as 8y, and that 2x is positive, so you can write positive 2x. You have to keep in mind that the sign that goes with the term is a result of when we combine the numbers. 5 minus 3, that's a 2, and that 2 is positive, therefore we write a positive sign. And at this point, go ahead and pause to complete the rest of exercise 1 and continue when you're ready for exercise 2. So here you go, continuing with exercise 1c. So we see 4x and we see negative 2x. So that will make 2x, because 4 minus 2 is 2, and it's an x term. And then positive 2y, positive 3y, together that makes a positive 5y. You have 5 s's plus an s, that makes 6 s's. And they have a positive 7t and a minus t. And keep in mind that minus t basically means minus 1. So 7 minus 1, this makes 6t, and that 6 is positive, so plus 6t. You always have to have a positive, a plus, a minus, a times, or division, a function to connect the terms. Moving on, you have u plus u, that makes 2u, and then you have 8v minus v, so that will leave you with positive 7v. You have in F 3r plus 4r, which leaves you with 7r's. Then 5s minus 2s's, which leaves you with 3s's. Now, moving on to exercise 2, it gets a little more complicated because now we have terms in which there are exponents. Even though they are all x's, the x itself versus the x squared, they belong to different families. They are different terms. So let's look at this. 2x's plus 4x's, that makes 6x's. Now, the 3x squared and the 5x squared, they are another family of their own. So this actually makes 8x squared. The x's and the x squares are not the same family. They're different terms. You cannot combine x's and x squares. So in this case, that 8x squared is a positive, so we'll put plus 8x squared. You can also reverse it as 8x squared plus 6x. It's the same thing as long as you maintain the quality of the value of the number, whether it's a positive or a negative. So at this time, if you have a sense of what to do, go ahead and pause. If you're not sure, go ahead and stay for one more example. 7y plus 2y, it gives you 9y. Positive 6y squared minus 3y squared, that makes you positive 3y squared. That's it. So at this time, continue. So here we go. 4z and 3z makes 7z. 2z squared and 2z squared together makes 4z squared. 8u minus 3u's will actually leave you with 5u's. 5u squared minus 2u squared, that leaves you with 3u squared. 5v minus 3v will make 2v's. 2v squared plus v squared gives you 3v squared. 8x minus 2x's leaves you with 6x. X squared plus 4x squared leaves you with 5x squared. Now, in this case, we're starting to solve linear equations with an unknown on one side. So if we look at these 4 simple equations, I'm sure you can look at it and understand how to do them mentally, which is fine. So if we look at example A, some number plus 3 makes 10. What is that number? In B, some number divided by 6 equals 4. What is y? In C, 3 times a number, because when you have a number next to a letter, it's basically implying multiplication. 3 times what number plus 6 makes 12. And then in D, 21 minus 7 times what number makes 7. So at this time, go ahead and pause and do this in whatever method that naturally makes sense to you. So if you did this mentally, you probably just said, oh, some number plus 3 makes 10. Well, I know that x has to be 7. And then you probably went on, so some number divided by 6 makes 24. What divided by 6 makes 24? Makes 4. Y is 24, because 24 divided by 6 makes 4. Then you asked yourself, what number plus 6 makes 12? So you probably were thinking to yourself, something plus 6 makes 12. Well, this has to be 6, so 3 times what makes 6? 3 times some number makes 6. This has to be 2. So A is equal to 2. Now in D, you're thinking 21 take away a number makes 7. So this has to be equal to 14. So 7 times what number makes 14? And you probably thought, oh, it has to be 2. So B is equal to 2. So those are your answers if you did them mentally. Now here's the thing. Because the algebra problems can only get more complicated, we actually have to practice writing our work out, and this is very specific. You need to write your work out. So we're going to go ahead and practice the same problems, but with a proper writing technique. So here we go. There are multiple ways in which you can actually write this out. So there's one way where you can move, you have to collect your like terms. That's why we did the first slide. So we have to ideally isolate the variable. We need to get that variable alone. So anything next to it, we need to move. So if we see this equal sign, that's basically, once we cross the equal sign, it goes to the other side of the balance. So ideally what we're trying to do is we're trying to balance the equation. So if we have to add 3 on the side, we actually have to subtract 3 on the other side. So this is how you would write it. X plus 3 equals 10. Well, I'm going to balance my equation by minusing 3 here, and what you do to one side of the equal sign, you have to do to the other side. And so what you have to do is make sure you really write the equal signs down in a straight line down the page. Now, positive 3 minus 3, that cancels because, well, they go away, and you bring down what's left over, the x. Important, bring down the equal sign exactly in the same line. And then 10 minus 3, well, that makes 7. And wasn't that your answer in the first problem? So that's one way to do it, where you actually have to use the inverse method, where you see plus 3, you minus 3. And what you do to one side, you do to the other because you're balancing your equation. Another way you can show it, I want to collect my like terms. I want to make sure I move things around so that the terms join with their like terms. So since I see a number 3 here and a 10, those are like terms. I need to move this over here. Now, the moment it crosses the equal sign, it becomes its opposite. So rewrite the problem as x equals 10 minus 3. And it becomes its opposite because plus 3 becomes minus 3. Then just shrink it down. 10 minus 3 is 7. And there we go. And we're done. And you know what? We can check it. 7 plus 3 makes 10. Is that correct? Check. Yes, it is correct. Now in the second one, you're probably thinking, well, how do I show this one? This is more complicated. Well, notice how it says divide by 6. The opposite is actually multiplying by 6. So you can show it like this. Y over 6 equals 4. So what we have to do is multiply it by 6. Multiply by 6. And the moment you multiply a division problem by 6, it cancels out. So all you're left with is y equals 24. Another way you can express this is, since you see it's dividing by 6, it's just like what we said. We want to combine our like terms by moving things across equal signs. So why don't we write y equals 4? And since that's divided by 6, why don't we write times 6? So y equals 24. Now, this is when it gets, the detail matters. So we have to do multiple things. We have to combine our like terms, and we have to isolate x, because to solve for x, we need to isolate it. So first, combine your like terms using either inverse method or by moving things around. So I'm going to choose to move the positive 6 over to the other side to join the 12, since they're like terms. So you're left with 3a is equal to 12. Now keep in mind, once it crosses the equal sign, minus 6. Combine your like terms, 3a equals 6. And notice I'm stacking my equal signs in one straight line. Then 3a equals 6. So you can ask yourself, 3 times what makes 6? Then you could just jump right in. A equals 2. But if you really want to be really formal about it, show me the division. 3a divided by 3 and 6 divided by 3. That cancels. And a equals 2. That's a more formal way of doing it. Now on the last slide, on the last one, it's the same idea. So at this time, can you pause and try to show out your work for D? So here we go. So for D, I need to combine my like terms. So I need to, now there's a lot of ways you can do this. Ideally, I like these terms that have variables to be positive. So I'm actually going to move this over here. So funny enough, when I move that over there, I have a 7 positive 7b, right? But you're like, wait, no, you have a term there. It's not a like term. You have to move it. So it's true. I have to move this over here now. So once you move it, it becomes its opposite. That positive 7 turns into a minus 7, which equals then 7b, because I just keep carrying things down. Now I can solve this. 21 minus 7 makes 14, which is 7b, and you can just say, oh, 7 divided by 7 is b, and 14 divided by 7 is just 2. Okay, and that's it. So this written method is very important because from this point on, the problems only get more complex. If you do not have a way of showing your work and writing it out, it's really hard to calculate everything mentally in your head, and you are more likely to make errors if you try to just keep everything in your mind. Write down the algebra. And that's it.